gambar tu masa sekarang tu. Foto atas tidak ada. Dan tidak ada. Saya buat itu macam orang kata secara tak orang kan. Buat announcement. Kalau isteri ada dua ramai-ramai yang tak dapat. Ramai-ramai kat sini.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, selamat pagi semua. Terima kasih diucapkan di atas kehadiran anda semua ke Majlis Syarahan Inaugural Profesor Insinyur Dr. Chin Yun Ling pada pagi ini. Di sini terdapat beberapa pengumuman untuk perhatian para hadirin sekalian. Pengumuman pertama, hadirin dijemput untuk mengambil tempat duduk dengan memenuhi ruangan hadapan sebelum majlis dimulakan. Yang keduanya, para hadirin haruslah memastikan telefon bimbit anda dimatikan ataupun diletakkan dalam mod senyap sepanjang majlis berlangsung. Dan pengumuman ketiga, hadirin diminta untuk berdiri ketika perarakan masuk tetamu kehormat kita dan diminta untuk kekal berdiri untuk nyanyian lagu Negaraku dan Putera Gemilang, dan seterusnya kita ada satu sesi bergambar selepas sahaja daripada habis menyanyikan lagu Putera Gemilang. Jadi bila saya minta untuk hadirin duduk, baru boleh duduklah semua. Okey, kerjasama semua amatlah diharapkan. Lagi satu, minta kepada siapa yang masih lagi perlu mendaftar, sila berbuat demikian. QR code disediakan di kaunter pendaftaran, jadi bolehlah mendaftar untuk sesi syarahan inaugural kita pada pagi ini. Kerjasama daripada anda semua amatlah dihargai. Terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Tuan-tuan dan puan-puan sekalian, insyaAllah majlis kita akan bermula sebentar saja lagi. Tetapi sebelum itu ada beberapa pengumuman yang ingin disampaikan di sini. Yang pertama, diminta kepada hadirin untuk menduduki ruangan di bahagian hadapan terlebih dahulu. Dan pengumuman kedua, sila pastikan telefon bimbit anda dimatikan ataupun diletakkan dalam mood senyap sepanjang majlis kita berlangsung pada pagi ini. Dan pengumuman ketiga, hadirin diminta untuk berdiri ketika perarakan masuk tetamu hormat kita dan terus kekal berdiri untuk nyanyian lagu Negaraku dan Putera Gemilang. Dan kemudian kita ada satu sesi bergambar selepas ada menyanyi lagu Putera Gemilang. Jadi terus kekal berdiri sampai selesai sesi bergambar tersebut. Kerjasama daripada anda semua amatlah dihargai. Terima kasih. Mengumumkan ketibaan yang berbahagia Datuk Profesor Dr. Muhammad Roslan Sulaiman, Naib Chancellor Universiti Putra Malaysia, diiringi Timbalan Naib Chancellor Akademik dan Antarabangsa serta ahli pengurusan Fakulti Kejuruteraan. Nyanyian lagu Negaraku dan Putera Gemilang. dipersilakan kekal berdiri bagi sesi bergambar. Hadirin dipersilakan duduk. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Yang berbahagia Datuk Profesor Dr. Muhammad Roslan Sulaiman, Naib Chancellor Universiti Putra Malaysia. Yang berbahagia Profesor Dr. Ismi Arif Ismail, Timbalan Naib Chancellor Akademik dan Antarabangsa Universiti Putra Malaysia. Yang berbahagia Profesor Insinyur Dr. Muhammad Khairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan Universiti Putra Malaysia. Yang berbahagia Profesor Insinyur Dr. Chin Yuk Ling, Profesor Jabatan Kejuruteraan Proses dan Makanan. Ahli keluarga yang berbahagia Profesor Chin, pegawai-pegawai kanan universiti, ahli-ahli fakulti kejuruteraan, tetamu-tetamu jemputan, para staf dan pelajar serta para hadirin sekalian. Selamat datang diucapkan ke syarahan inaugural oleh yang berbahagia Profesor Insinyur Dr. Chin Yuk Ling. Untuk makluman para hadirin sekalian, syarahan inaugural ini dilaksanakan secara hybrid, di mana ia juga dipancarkan secara langsung melalui Facebook UPM dan Facebook Fakulti Kejuruteraan. Para penonton yang menyertai majlis ini secara dalam talian dialu-alukan untuk menekan butang like dan share melalui halaman Facebook tersebut, dan dimohon kerjasama untuk mengisi kehadiran melalui pautannya yang dikongsikan melalui ruangan komen di Facebook untuk sijil penyertaan dan mata latihan CPD bagi staf UPM. Baiklah para hadirin sekalian, bagi memberkati majlis syarahan pagi ini, majlis ingin menjemput Insinyur Dr. Muhammad Effendi Yaakob bagi memimpin bacaan doa. Dipersilakan.
Bismillahirrahmanirrahim. Ila hadratin Nabi Mustafa Rasulullah sallallahu alaihi wa alihi wa sahbihi wa baraka wa sallam. Kiram al-Fatihah. A'udzu billahi as-sami'il 'alim minasy syaithanir rajim. Bismillahirrahmanirrahim. Alhamdulillah, alhamdulillah, alhamdulillahi rabbil alamin, hamdan yuafi ni'amah wa yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhikal karim azim sultanik. Allahumma salli ala sayyidina Muhammadin al-Fatih lima ukhliqa wal khatim lima sabaqa wal nasir al-haq bil haq wal hadi ila siratikal mustaqim wa ala alihi wa sahbihi haqqa qadrihi wa miqdarihi al-azim. Allahumma ghfir lana dzunubana wa liwalidina warhamhuma kama rabbayana saghira. Ya Allah, ya Wajid, ya Rahman, ya Rahim, ya Syakur, sesungguhnya kami memanjatkan kesyukuran kepadamu di atas segala nikmat dan rahmat yang telah Engkau kurniakan kepada kami semua, kedua ibu dan bapa kami, ahli keluarga kami, sahabat handai kami, guru-guru kami serta seluruh warga Universiti Putra Malaysia. Ya Allah Al-Muiz, Kau berikanlah kami kekhusyukan di majlis yang berbahagia inaugural Profesor Insinyur Dr. Chin Yuk Ling pada hari ini, supaya kami tergolong dalam kumpulan yang Kau muliakan serta Kau muliakanlah semua kami di sini yang terlibat dalam menjayakan majlis kami ini. Ya Allah, Ya Fattah, Ya Wadud, kami memohon kepadamu Ya Allah supaya majlis inaugural yang berbahagia Profesor Insinyur Dr. Chin Yok Ling ini Kau berikanlah kelancaran baginya, dipermudahkan dan diakhiri dengan beroleh kejayaan. Ya Allah Al-Basid, Kau buka luaskanlah pintu-pintu ilmu supaya dapat kami manfaatkan dalam ibadah pekerjaan kami sebagai sebahagian usaha kami meningkatkan kecemerlangan diri serta Universiti Putra Malaysia dengan kuasa-Mu Al-Khaliq. Ya Allah Al-Muqid, Kau bukakanlah jalan kejayaan serta kekuatan kepada kami dan generasi-generasi selepas kami untuk kami memartabatkan serta menyintai ilmu-Mu Ya Rahman. Ya Allah Al-Qudus, Kau sucikanlah serta Kau peliharakanlah hati-hati kami sepanjang ibadah pekerjaan kami di Universiti Putra Malaysia ini dan hidup seharian kami bersama keluarga, sahabat handai dan guru-guru kami supaya kami menjadi hamba-hamba-Mu yang Kau redai. Ya Zal Jalali wal Ikram, tambahkanlah kami kepada kecintaan segala kebaikan. Jadikanlah kami, guru-guru kami dan pemimpin-pemimpin kami terus berkhidmat dengan istiqamah untuk menabur bakti, membangunkan umat, masyarakat, bangsa dan agama. Ya Allah, Ya Tuhan kami, jadikanlah negara kami sebuah negara yang mendapat limpahan rahmat dan nikmat. Kekalkanlah keamanan dan kemakmuran sepanjang zaman. Ya Zal Jalali wal Ikram, la ilaha illa anta subhanaka inna kunna minaz zalimin. Allahumma barik lana fi Ramadan. Allahumma barik lana fi Ramadan. Allahumma barik lana fi Ramadan. Allahumma rabbana hab lana min azwajina wa zurriyyatina qurrata a'yun waj'alna lil muttaqina imama. Allahumma amin. Allahumma amin. اللهم آمين. اللهم ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وقنا عذاب النار وقنا عذاب النار وأدخلنا الجنة مع الأبرار يا عزيز يا غفار يا ستار يا جبار يا رب العالمين. وصلى الله على سيدنا محمد وعلى آله وصحبه وبارك وسلم والحمد لله رب العالمين. الله منا ومنكم.
Terima kasih diucapkan kepada Insinyur Dr. Muhammad Effendi Yaakob di atas bacaan doa sebentar tadi. Para hadirin sekalian, majlis diteruskan dengan tayangan video Jabatan Kejuruteraan Proses dan Makanan. Sama-sama kita saksikan.
Essential part of our lives, the very thing that provides nourishments for our body. But do you know that before it can become the everyday food we consume, it must first go through various processes? And today, we will explore a little bit of that untold story. Before food is put on the store shelves for sale, it must first undergo various processes. These processes require specific and substantial knowledge. The knowledge in food processing and engineering. This knowledge makes bulk food processing and engineering more efficient and economic. As a result, a competitive and affordable price can be offered to consumers. To achieve this, in addition to having substantial knowledge and skills in food processing and engineering, access to an optimized and advanced food processing plant is also imperative. And so, we open our door to those who share the same aspirations and ideals as us. The Department of Process and Food Engineering delve deeper into the nature's secrets in agricultural process engineering, discover and develop new methods of processing that will make food safer and cleaner in food engineering, study the wonders of food biology in biochemical engineering, invent and innovate packaging to a new level in packaging engineering, and be inspired by the great minds and talents here in the Department of Process and Food Engineering. Be a part of the leading department in food safety and sustainability. help us to discover even more efficient, cleaner and safer food engineering processes. Come and join us. Together, we engineer food for a better future.
Terima kasih. Para hadirin sekalian, kini majlis menjemput yang berbahagia Dato' Profesor Dr. Muhammad Roslan Sulaiman untuk mempengerusikan syarahan inaugural ini dan seterusnya menjemput yang berbahagia Profesor Insinyur Dr. Chin Yuk Ling untuk menyampaikan syarahan inaugural beliau. Dengan segala hormatnya, majlis mempersilakan.
Bismillahirrahmanirrahim. Terima kasih saudara pengacara majlis. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Yang berbahagia Profesor Dr. Ismi Arif Ismail, Timbalan Naib Chancellor Akademik dan Antarabangsa Universiti Putra Malaysia. Yang berbahagia Profesor Insinyur Dr. Muhammad Khairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan Universiti Putra Malaysia. Yang berbahagia Profesor Insinyur Dr. Chin Yuk Ling, Profesor Jabatan Kejuruteraan Proses. Yang berbahagia Profesor Insinyur Dr. Wan Azlina Wan Abdul Karim Ghani, Timbalan Dekan Akademik Hal Ehwal Pelajar dan Alumni Fakulti Kejuruteraan. Yang berusaha Profesor Madya Dr. Eddie Sham Zainuddin, Timbalan Dekan Siswazah dan Antarabangsa Fakulti Kejuruteraan. Ahli-ahli keluarga Profesor Dr. Chin, Mr. Wong, very beautiful two children. Yeah. Okay, minggu depan sekolah. Pegawai-pegawai kanan universiti, ahli-ahli Fakulti Kejuruteraan, tetamu-tetamu jemputan, para pelajar serta hadirin hadirat yang saya hormati sekalian. Alhamdulillah, bersyukur kita kepada Allah Subhanahu Wa Taala kerana dengan limpah kurnianya dapat kita bersama-sama pada pagi ini untuk meneruskan usaha memertabatkan kesarjanaan ilmu. Izinkan saya untuk membacakan sedikit latar belakang Profesor Insinyur Dr. Chin Yuk Ling dalam majlis yang penuh gemilang ini. Chin Yuk Ling dilahirkan pada 15 Mei 1977 di Melaka. Tempatnya dia tak sebut. Beliau telah mendapat pendidikan awal di Sekolah Rendah dan Menengah Infant Jesus Convent Melaka. Beliau telah meneruskan pengajian di peringkat diploma kejuruteraan pertanian dan dapat naik taraf ke program Bachelor Kejuruteraan Proses dan Makanan pada tahun 1996 di Universiti Pertanian Malaysia, UPM. Dulu dikenali sebagai Universiti Pertanian. Dan di sini juga dia berjumpa dengan Mr. Wong. Wong suruh saya beritahu. Setelah bergraduat pada tahun 1999, beliau telah melanjutkan pengajian ijazah PhD di University Manchester Institute of Science and Technology, United Kingdom, dalam bidang kejuruteraan kimia. Sepanjang pengajian di universiti, beliau mempunyai pengalaman yang unik, iaitu semasa pengajian ijazah sarjana muda, universiti telah bertukar nama dari Universiti Pertanian ke Universiti Putra Malaysia. Manakala semasa pengajian ijazah PhD, universiti pula bertukar nama dari UMIS kepada University of Manchester. 2 kali. Saya harap kali ketiga tak berlakulah. Takut Prof tukar nama pula nanti. Sidang hadirin yang dimuliakan sekalian, kerjaya akademik beliau bermula setelah mendapat tawaran menjadi tutor di Fakulti Kejuruteraan UPM. Dengan beasiswa UPM, beliau telah berjaya menamatkan pengajian PhD pada tahun 2003 dan telah kembali berkhidmat sebagai pensyarah di Jabatan Kejuruteraan Proses dan Makanan Universiti Putra Malaysia. Kerjaya beliau sangat cemerlang, di mana beliau telah dilantik sebagai profesor penuh pada tahun 2016, iaitu selepas 6 tahun 7 daripada pensyarah kanan 4 tahun, Profesor Madya 3 tahun, dan selepas itu profesor dalam masa 6 tahun. Betul sungguh cepat. Dan sepanjang 20 tahun berkhidmat sebagai seorang ahli akademik, beliau telah mendapat pelbagai pengiktirafan, termasuk anugerah pensyarah pilihan 2011, anugerah fellowship Naib Chancellor 2012, iaitu penyelidik muda, mendapat finalis dalam anugerah fellowship Naib Chancellor 2009 untuk pengajar muda, dan pencalonan anugerah akademik negara 2011 dan 2015. Bagi tepukan. Dan beliau juga telah dipilih oleh Mr. Wong. Dan sepanjang penyelidikan beliau sebagai seorang pensyarah, beliau telah menggraduatkan seramai 58 pelajar bachelor, 17 master dan 8 pelajar PhD. Dalam bidang penyelidikan, beliau telah berjaya mendapat geran melebihi ringgit Malaysia 1.9 juta secara tunai untuk 20 projek di peringkat nasional, antarabangsa dan juga swasta. Beliau berjaya mendapat geran Newton Engku Omar Research Links pada tahun 2016 untuk projek pemprosesan makanan menggunakan inovasi pengudaraan. Beliau juga telah memfailkan satu paten untuk sistem menaikkan kualiti makanan menggunakan teknologi pengudaraan dan ultra bunyi. Kini beliau mempunyai sebanyak 173 penerbitan jurnal dengan Scopus H Index 31. Jalinan kerjasama pengajaran dan penyelidikan beliau dengan universiti dan institut lain di dalam dan luar negara, termasuk United Kingdom, India, China, Kazakhstan, Pakistan dan juga Singapura. Manakala projek perundingan pula kebanyakannya adalah dengan syarikat makanan. Sidang hadirin dan hadirat yang saya muliakan, Prof Chin merupakan seorang jurutera profesional berdaftar dengan Lembaga Jurutera Malaysia dan jurutera bertauliah yang berdaftar dengan Engineering Council UK. Beliau juga merupakan pengurusi bahagian teknikal kejuruteraan pertanian dan makanan Institut Jurutera Malaysia dan ahli Young Scientist Network Academic Science Malaysia. Beliau pernah menjawat jawatan Ketua Unit Jaringan Industri dan Masyarakat di fakulti pada tahun 2015 dan berbekalkan minat yang mendalam dalam bidang kejuruteraan makanan, beliau terus bergiat dalam mengaplikasikan pengetahuan pemprosesan makanan ke tahap yang lebih relevan dan bernilai untuk kebaikan sejagat. Sidang hadirin hadirat yang saya hormati sekalian, tanpa membuang masa, sebelum saya menjemput Prof Chin untuk memberi syarahan inaugural beliau, saya memohon maaf kerana tak dapat terus bersama untuk mendengar syarahan pada pagi ini. Namun saya amat berbangga, saya mewakili seluruh warga UPM, amat berbangga dapat mempengerusikan sementara sekejap bagi inaugural pada pagi ini untuk salah seorang profesor yang cemerlang di Universiti Putra Malaysia. Dan saya berharap Prof Chin akan terus memberi sumbangan yang baik kepada universiti dan juga menjadi role model bukan hanya kepada rakan-rakan sejawat tetapi juga kepada pelajar dan paling utama kepada anak-anak. Jadi tanpa membuang masa, marilah kita mendengar syarahan inaugural oleh Profesor Insinyur Dr. Chin Nyok Ling bertajuk Engineering Food via Aeration and Authentication for Quality, Health and Sustainability. Saya dengan segala hormatnya dan penuh takzim menjemput Profesor Chin untuk ke pentas. Silakan.
This one is for the salutation. Oh, for salutation. Okay, thank you. Salam sejahtera para hadirin sekalian. Terima kasih saya ucapkan kepada Tuan Pengacara Majlis, Teknologis Dr. Muhammad Zuhair Muhammad Noor dan Tuan Pembaca Doa, Engineer Dr. Muhammad Effendi Yaakob. Yang berbahagia Datuk Prof. Dr. Muhammad Ruslan bin Sulaiman, Naib Chancellor Universiti Putra Malaysia. Yang berbahagia Prof. Dr. Ismi Arif Ismail, Timbalan Naib Chancellor Akademik dan Antarabangsa. Yang berbahagia Prof. Engineer Dr. Muhammad Khairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan, Ahli Pengurusan Fakulti, rakan-rakan industri, rakan-rakan pensyarah di UPM, IPTA dan IPTS, pelajar-pelajar, ahli keluarga saya serta penonton secara maya iaitu di Facebook Live. Saya ucapkan terima kasih kepada semua kerana sudi hadir. Setinggi-tinggi penghargaan saya kepada Yang Berbahagia Datuk Naib Chancellor yang dapat datang dan mempengerusikan majlis syarahan inaugural saya pada pagi ini. Terima kasih, Datuk. Boleh simpan. Di pagi yang indah dan amat bermakna untuk saya sekali lagi merakamkan ucapan terima kasih kepada semua kerana sudi meluangkan masa berharga anda untuk menghadiri majlis syarahan inaugural saya, yang merupakan inaugural lecture series yang ke-276 di UPM. Syarahan ini telah saya reka seboleh-bolehnya untuk pemahaman secara awam walaupun setengah istilah masih agak teknikal. Saya berharap para hadirin sekalian mendapat sedikit pendedahan baru dan perkongsian pengetahuan dan pengalaman saya dalam bidang akademik dan penyelidikan yang berasaskan makanan. Tajuk syarahan inaugural saya ialah pengesahan pengudaraan. Tajuk syarahan inaugural saya ialah kejuruteraan makanan melalui pengudaraan dan pengesahan untuk kualiti, kesihatan dan kemampanan, atau dalam bahasa Inggerisnya engineering food via aeration and authentication for quality, health and sustainability. Untuk meningkatkan kelancaran pengucapan, saya meminta izin untuk menyampaikan syarahan saya dalam bahasa Inggeris. This is the overview of my lecture in 2 sections. I shall begin with food engineering, giving some information about this new field and program. I will illustrate food engineering using 2 subjects, food aeration and authentication, as both are my favorite. The aim is to provide understanding that helps both the processing and food products to achieve better quality and contribute to health and sustainability, which makes the second section. The engineering mindset and approach to understand food processes will by means of using technology, analysis, and modeling. Through the understanding of physical, chemical, and biological properties of food. After being in the field of food processing research for almost 20 years, or 20 years plus, I've collected thoughts that I think it is nice to share with you all. My questions to people are always food. Do we eat food to fill our tummy? Do we eat food to grow and for activities? Or do we eat food for nutrition and health? Or do we eat for pleasure or maybe beauty? Or a mixture of some of those mentioned? So preparing and processing food have many levels of its need. Those questions also help us to align and to react. It also helps us to discipline ourselves in the course of our lives where we make our own choices. In a way, food engineering training has made me quite a rigid person. What do I mean by rigid here is sometimes when we go for grocery shoppings, me and my husband, we will have fights or maybe arguments, all right? I simply cannot accept buying foods that do not give too much benefits. So much so, my husband says, we should add some colors to our life and let the kids eat some junk so that they experience childhood. So, who says that we need junks to have childhood? So, well, it is an open thing, so I would say that as long as we keep a good balance between the rational and emotions, we should be fine. So what food engineering has taught me, this program was introduced in UPM in the late 90s. Till today, it may still be new to some. Food engineering program is more heard of in the States, and apparently in Turkey, a food company requires only certified food engineers to work in their factories. I was very fortunate to have enrolled in a program, knowing little what it was, but later it became the axis of my career. Food engineering is a multidisciplinary field involving agriculture engineering, chemical engineering, mechanical engineering, and also the knowledge of food science and technology. During its establishment years, there were many challenges due to lacking of recognition and self-identity. But today, it is quite a full-fledged engineering program with a department of 30 full-time academic staff. Students are trained to visualize food processes such as drying, freezing, heating, mixing, those operations that we do and deal with in the kitchen. As unit operations, thus mathematical equations are involved. Through equations, modeling and optimization are performed to improve process efficiency and also product quality. Ultimately, the food engineering outcome is to provide quality food, which benefits society in terms of good health with environmental concern for sustainability. Now, into food aeration, my favorite subject. Air is present inconspicuously in our food. We may have overlooked. Cakes and breads that we eat every day actually contains very high amount of air, 70% to 85%. 70 to 85%. And popcorns are 95% air. I often joke to my students in the class, saying that the next time when you buy cakes, breads, or even ice cream, check that if you are paying it by weight or by volume. If you are paying by volume, you are also paying for the air. Okay? It's something like when we pump petrol to our vehicles. Do we pay in volume or do we pay in the weight? Let's think about it. Okay? So food aeration refers to physical processes of air occlusion into the food matrix during processing for intended reasons. So what is the importance of bubbles in food? Mostly, it concerns palatability. It eases the eating and the chewing process and contribute to textural and mouthfeel properties, thus gives us pleasure and sensation during eating. I would say in most foods that we eat, we have not realized that the presence of air does make a big difference in enhancing our liking. Beyond textural and the mouthfeel contributions, scientifically, aerated food is also advantageous in giving better digestibility and contribute towards satiety. Satiety is a feeling of full by eating less. Thus, aeration has been used to address some health and obesity issues. For example, I choose these two foods, which are very highly recognized for its aerated structure. Gas injection into chocolate to make aerated chocolate bars. Peek inside your bags, okay? The famous aero bars in the UK. And the other highly aerated food, the croissants, are made by very careful layering steps to create highly aerated structures. To maximize the bubble sensation for these two foods, I suggest that for the aero bar, keep it inside the refrigerator when you get home, but just before eating it, take it up to the room temperature and wait for about 10 to 20 minutes or until the temperature rises again to about 18 to 20 Celsius, then eat it. Feel the melting sensation as the chocolate crust breaks, reaching the internal foamy part. Okay? As for the croissant, it is suggested to heat it up in a toaster or in an oven at 130 or 150 Celsius for about 2 to 3 minutes until it gets a hard shell or the crust. You can eat it plain, but if you were to eat it with butter and if you are slicing it up, use a very sharp knife as to not destroy the bubble structure. Okay? The aero bars in your bag were bought during Christmas from village grocers, and they are not regular products by Nestle in Malaysia. So if you look at the date, please have it soon. Don't keep it any longer. It was end of December that I bought all of them. I sapu from all the grocers, the ones that I can reach, and I have been. So in studying food aeration, quantification of air in food is necessary in order to have a very accurate measure and analysis. So take a piece of popcorn as an example, the one with 95% air. It is a bite-sized food. Pop, it goes into our mouth. It is light and full of air as we see how much air is inside the popcorn when we compare to the size of the corn kernel on its left. It's small and this is big. What does it include? It has air inside. So we measure gas content from the difference in the volume between the two, the popped and the corn kernel. So when we take the envelope volume minus the true volume, which is the black area, we will know the air content. True volume is the volume of actual mass, or when the food is crushed to expel all of its air. When we have a box of popcorn like the ones we have in the cinema, what we refer is the bulk volume. So, similarly, when we have a food that is bigger than a bite size, for example, a loaf of bread, the bulk volume minus the true volume, this time round the true volume is the white area. Due to the scanning method of white bread, we also get the volume. We also get the gas content, sorry. So in measuring gas content, accurate quantification of volume is very important. And for measuring volume of food particularly, it is very challenging due to the irregular shapes and size of food, plus the chemical and the biological sensitivity to the environment. The concept of volume displacement is applied, either by solid, liquid, or gas, using various instruments and experimental setups. It is something like how Archimedes discovered his own body volume from the bath water displaced, in this case the liquid displaced, as he excitedly leaped out from his bathtub in a eureka moment. So this iconic statue, I like to use him to illustrate, because this is in UMIST, and I used to walk past this statue every other day. Those who visit UMIS or University of Manchester, please look for this statue. So gas content is essentially the fraction of voids. Voids is ruang, okay? The tempat yang kosong, yeah? Taken away from the fraction of mass. Remove the mass, okay, in the volume, or it is therefore known as gas void fraction. So for a standard mass, say 5 gram, okay, a bigger volume, okay, 10 centimeter cube, to a small volume, 1 centimeter cube, with a standard mass, we will have a lower density when the volume is higher. So therefore, with constant of mass all the time, whether it is with air or without air, the equation of gas void fraction can also be interpreted using density. So these two equations describe the gas contents in food quite adequately. Nice food. Here is a list of local food which gas contents were measured by means of suitable volume displacement, mostly using solid and gas. I thought it is interesting as we never realized some of our common everyday food has very high gas contents. For example, the sugar rice cake. I made this myself. The sugar rice cake has up to 70% air. Kueh bahalu has 75% air. I made it myself. Gluten bowls are 95% air. I made all of them actually. And the appam balik contains 60% air. Surprising, right? So these foods were prepared in a home kitchen using normal cooking process of either steaming, baking, or frying. So air is incorporated during our everyday food preparation, and the methods of aerating food are mainly categorized into 3. The first is by mechanical actions of stirring, mixing, beating, or whisking, which we do always in our kitchen, thinking we are just performing some mixing or homogenizing as a blending process. We will notice the difference in our food when air is incorporated, such as when making scrambled eggs, or even in the teh tarik, when we have it in a mamak store. So the teh tarik that is non-tarik and with tarik is different. I'm sure you notice. Now the second aeration method is using agents, right? Which can be biological, mainly yeast, or chemicals using baking powder or baking soda. As we know, these are quite a compulsory ingredient when we make breads and cakes. And thirdly, is by use of heat, where water converts into steam and expand in volume during baking, frying, or even steaming due to the rise of temperature above boiling point. In the food industry, food manufacturing processes involving aeration can be very interesting subject that comes with innovations and inventions of new products. For example, the carbonator makes soda and soft drinks fizzy. My son loves that. Okay. The chocolate aerator makes bubbly chocolates. He also loves that. And the ice cream aerator makes smoother and tastier ice cream. He does love that too, okay? So he loves all the aerated things. I was introduced to the Chorleywood bread making process as one example of an aerated process during my PhD. The bread making process was an invention that allowed breads to be made easily and economically with low protein British wheat by using an enclosed high-speed mixer that can be adjusted to positive and negative pressures. Interesting. How can we mix something under vacuum? So it uses aeration effects. And these mixers are called the Tweedy mixers. So the negative pressures here refers to partial vacuum. Today, more than 80% of the breads in the UK are made using industrial Tweedy mixers. The process was invented by the Chorleywood Flour Milling and Bakery Research Association, famous CCFRA in the UK, in the 1960s, and has given the bread industry a push into a modern era with very high competitiveness in terms of cost and consumer needs. Just if any of you noticed the minor mouthfeel difference when eating white bread in the UK and at home here. So the interesting thing about it is the Tweedy mixers. The picture on your left is fabricated scaled down Tweedy 1 mixer, 1 meaning 1 pound, so to mix 1 pound of flour for lab use and research. I use it a lot in my PhD study. The picture on the right is a Tweedy 10, meant for 10 pounds of flour. So the picture was taken with Prof. Grant Campbell, my PhD supervisor, during the aeration workshop supported by the Newton Ungku Omar Grant in the Bread Research Institute in Camden, UK. So my days of research on aerated food products continued with projects until the idea of power ultrasound to improve aerated food came by. The power ultrasound was adopted in an existing mixing system to enhance aeration of bakery products. This is a power ultrasound mixing system incorporated into a mixer. The developed system was patented in 2011 after many trials and testings. So the cavitation effects from the ultrasound gives better aeration in terms of more stable and consistent bubbles that give much improvements to the textural properties, which also suggests reduced usage of ingredients like rising agents and stabilizers, mostly emulsifiers. So typically, ultrasound is a series of sound waves with frequencies above our human hearing of 18 kilohertz. So it's above, so it's higher, between 20 kilohertz to 10 megahertz. The lower frequency of the ultrasound from 20 kilohertz to 2 megahertz is known as power ultrasound, whereas the higher range from 5 megahertz to 10 megahertz is diagnostic ultrasound, the ones we use mainly in the medical and industrial imaging purposes. The ones pregnant mummies go to the hospital and you do the scanning, it is also ultrasound, but it's diagnostic ultrasound. Due to the nature of non-thermal and a clean process, power ultrasound is favorably used in the food processing to initiate changes to alter properties of a material through chemical, mechanical, and or biological effects of the products like crystallization, extraction, homogenization, and even drying. So the ultrasound cavitation effects are particularly very good in creating bubbles. Within the liquid medium, intense sound wave produces fluctuations. Okay? Fluctuations in a successive cycles, that means continuously, okay, in alternating expansion and compression pressures that results in the formations of small little bubbles that will grow, okay, slowly until it reaches an unstable size, and due to very high pressure and temperature within the bubble, it will explode, it will burst into many smaller bubbles. So what we did in the lab was, in the sponge cake trials, the applications of ultrasound during mixing showed desirable changes of lower batter density. Batter density, that's the liquid cake that we make before baking. We call it batter, the batter density. So lower batter density means higher air contents. In liquid system, the air occluded inside the batter is commonly known as overrun. People who deal with ice cream processing will know what is overrun. Okay, overrun is the amount of air into the liquid system during aeration effect. So what we see here in the graphs is that there was great improvements, and in terms of volume improvement of cakes, 4% was measured. In terms of textural properties, ultrasound exposure was also found to give quality improvement to the cake when we eat it, as when we bite it. in terms of lower hardness, so we have softer cakes, lower gumminess and chewiness. When we eat cake, we want to bite and it breaks. We don't want to chew the cake. So it has lower gumminess and chewiness by 10%. And what we want is higher springiness, cohesiveness, and resilience compared to control. So something desirable in terms of cake properties. Let me introduce to you about the angel food cake. The angel food cake is a recipe that depends highly on the usage of eggs as foaming agent to make rice. It doesn't use chemical leaveners. So eggs are also the most favorable natural ingredients to make cake rice instead of using chemical leaveners like the stabilizers. So in making cakes without using eggs, we replace it with whey proteins. And usually cakes made from whey proteins are not so nice and edible. But with ultrasound treatment during the mixing process, we found good results. Ultrasound was helpful. With ultrasonic assisted mixing, the batter overrun, that's the air content, improved significantly by 18%. The measured cake volume also increased by 22%. Cake volume and density made using whey protein concentrate was almost comparable to those made using eggs. So, meaning whey protein now can replace eggs for those who have eggs concern, can't take eggs. Excellent improvements were measured for the textural properties with reduced hardness and chewiness of cakes when using whey protein. So besides making cakes, we also made breads. Okay? In addition to the mixing process, the power ultrasound was also used in the proving process. Proving process is a stage whereby bread dough will just rest and wait for it to increase in volume before it gets into the oven. So an experimental rig was set up to replace the normal proving cabinet. Usually we put it in a cabinet and we control the temperature and we control the humidity. Now this is something that we devised with the ultrasonic hook on. Not inside the cabinet, not under controlled humidity and temperature. So in these graphs, when we see the control, it's down here without using ultrasound. Once we add ultrasound and add the time of treatment, we find there's great improvement. The increase of volume was by 19%, and during mixing and during proving, improvement was 17%. So in terms of textural properties, that's the firmness of breads made with mixing and proving ultrasound treatment. Firmness decreased 34% and 27% for the mixing and proving respectively. So we have softer breads. Well, my students have just used the white bread to study in the research for simplicity. And we discovered that the duration of treatment was more significant than the intensity of ultrasound. So that is one thing that we found. And all these results on improvement of aeration were very well supported by studies using crumb properties, where we do detailed analysis of the bubble size in terms of number and also sizes with very advanced imaging techniques. Moving on from food aeration, we go to food authentication. My research on food authentication focused on two foods, again my favorite, honey and edible bird nest. These two foods are very commonly targeted for food fraud due to its high economic value. Edible bird nest is the solidified saliva of swiftlets, the edible ones. The authentication work was to identify their origins in terms of composition, purity, geographical location, and production methods. So chemistry and biological methods were used with the utilization or engineering approach of modeling to handle the multi-compositional data. Because the biological and the chemistry methods used are common. But what we deal with is we have data. How do we analyze and how do we perceive? What meaning does it give to us? To introduce honey to you, honey from our region is obtained from 2 bee tribes. The honey bees, every time we say honey, we say honeybees, okay? And they come from the Apis genus. And there's one type which we call the stingless bee. They are much smaller and they do not have a sting. They are called the Trigonas genus. They come from the Trigona genus. So the Apis mellifera, one of the honeybee species, is the most widespread honeybee in the world. And they build hexagonal shaped combs with wax in their nest to produce comb honey. What we often take and often see here. The stingless bees are mostly found in the tropical and the subtropical regions, for its honey have very high medicinal features and even healing qualities. So they produce pot honey that are stored in constructed horizontal pots made of cerumen, which is a mixture of propolis and wax. We call them the kelulut honey in Malaysia. How many of you have come across a kelulut? Kelulut honey. Yeah, it's getting more and more common, kelulut honey in Malaysia. So the identification of honey was done to its bee species origin. Now I have a honey. What honey it is? You usually use botanical and geographical origin to name it. For example, this comes from tualang tree, gelam flowers, or pineapple fruit. Okay, so it's either we use the botanical names or the geographical origin. We say this is Borneo honey. Okay, this is Iranian honey, or this is New Zealand honey. Okay, but what we did was we wanted to identify honey coming from which bee species, and not by their botanical names and not by their geographical location. For edible bird nest origin, we wanted to trace its production in terms of whether it comes from house or cave, because of late, we not only get edible bird nests from the natural caves, there are also people rearing the swiftlets and get the edible bird nests from houses. Geographical location, whether it comes from the Peninsular Malaysia or East Malaysia, or whether they are from swiftlet species Fuciphagus, the white nest, or Maximus, the black nest. There are 2 types of nests, the white and the black. So this is a very long list of chemical properties which included physical chemical properties, nutritional and antioxidant properties that were studied. Why? We wanted to find the markers that will help us identify the origin of honey and the EBN, edible bird nest, to their origin. Whether they come from which species or whether how they were made by house or cave, and etc. So pattern recognition methods via unsupervised and supervised algorithms were used. Principal component analysis PCA, hierarchical cluster analysis HCA, were examples of the unsupervised, and the linear discriminant analysis LDA was the supervised algorithm used to determine the markers. So results. Honey. For honey, the stingless bee was found to be differentiable from the honeybees honey by its higher moisture content, free acidity, color intensity, antioxidant activities, and higher protein contents. The 2 honeys also have very different sugar profiles, because the stingless bee honey, the kelulut, has less sugar of fructose and glucose. So it's less sweet. For edible bird nest, samples collected from the house, the white nest, and originated from Peninsular Malaysia has higher sialic acid. This is an important parameter in the EBN for quality, and also higher antioxidant properties. But mineral contents were higher for the edible bird nest coming in from the cave, East Malaysia. The amino acids profiles for the white and black nest are also significantly different. So in terms of mineral content, this is also interesting. The major elements in honey are sodium and potassium. The major elements in edible bird nest are also sodium but calcium. The levels of the minerals are about 10 times higher of that in edible bird nest than honey. So antioxidants. I was particularly very interested in antioxidant properties, so we made 4 different measurements, technical terms here, AEAC, FRAP, DPPH, and TPC. Researchers will know about this. But the first 2, AEAC and FRAP, have shown the most dominant parameters that can differentiate honey between the stingless and the honeybee honeys. So in this research, we use honey Manuka as our benchmark. Manuka is famous New Zealand honey. The Manuka honey has the highest antioxidant property, followed by Kalulut, which is a stingless bee, and then a range of the Apis species honey, the honeybee honeys. The antioxidant values of all the Apis honeys, Tualang, Gelam, Pineapple, and Borneo, were not significantly different. I have always wanted to use antioxidant levels in food as a parameter to indicate food quality. We are still trying on this, trying very, very hard in our publications to see if it can be accepted. Honey from stingless bees, the Kalulut, was differentiable from honey from the honeybees with the application of principal component analysis, as we see here, where we see there are 2 significant classifications of these 2 groups identified by the different colors, the pink and the blue. So the physical chemical properties and antioxidant properties can be said are useful markers to differentiate the honeys. So the hierarchical cluster analysis HCA was also displaying the same thing, where we see clear clustering of honey produced by the 2 different bee genera. To the EBN, edible bird nest antioxidants, 3 properties were measured: TPC, DPPH, and FRAP. So what we found was that the house nest, the white nest, Fuciphagus, and those coming from Peninsula had higher and stronger antioxidant effects by 2 times than the cave, black nest, and East Malaysia. So you can make some conclusion, or you can decide something after knowing this. Now the following graphs show very clear clusters of the edible bird nest following production origin, whether they come from the house or they come from the cave. On the left, you see the PCA plot. On the right, you see the HCA dendrograms. Similarly, that goes to clustering following species, where we have the white nest, Fuciphagus, and also the black nest. And in terms of geographical origins, we see edible bird nests coming from the east or peninsular Malaysia. So moving on from physical bubbles to chemical properties, the biological based DNA method was then used in our identification study, as it is still the most accurate approach of determining origins of honey and EBN. Basically, DNA-based method was approached in 4 steps. First, DNA extraction, where we have used commercial kits. Then PCR amplification. It is a process that we amplify DNA template to produce specific DNA fragments. Followed by DNA sequencing, where we prive genetic information of a particular DNA segment to confirm the species identity. And lastly, phylogenetic analysis, where we do construction of a tree-like pattern to describe the evolution of a certain species. So in our research, the biggest challenge was to harvest bees' DNA from honey. Honey is a very complex matrix. with very high sugar content, up to 75%, and consists of a multitude of plants, insects, and bacteria, and even fungal sources. So identifying honey based on its bee species was very new and less explored. So the idea came from the thinking of possible traces left behind the bee's regurgitation process, biting and chewing, from chewing of the collected nectars, mostly sucrose, with its enzyme to digest into honey in the form of fructose and glucose during the honey making process. So it shows here coming from the stomach and the chewing, the regurgitation, and then it will be stored in the hive. And after some time, some water will get evaporated off, so honey become drier. That's when we call the honey sudah matang, belum matang, boleh dipungut ke tidak. Okay, so this goes to honey after it reaches a certain maturation in terms of sugar level and also water content. So in extracting DNA and identifying new primer sets, gene markers are very important, and they were obtained from two parts of an animal cell. As we know, in an animal cell, we have the nucleus and the mitochondria. Okay, in this case, harvesting bees' DNA from honey and harvesting swiftlets' DNA from the edible bird nest. So from the many experiments done, the gene regions that work in identifying honey by its species were from the mitochondria, not the nucleus, mitochondria, being 16S rRNA and the mitochondria cytochrome C oxidase subunit 1, CO1 we call it. For the EBN, there were 3 types of genes that could become the markers from the mitochondria and 1 gene from the nuclear region. The 3 from the mitochondria are cytochrome B and D2 RNA. The one coming from the nuclear DNA is the beta fibrinogen intron 7 gene. So, taking example of the 16S rRNA for honey, the extracted DNA was amplified using primer sets designed at 300 base pair length, slightly shorter, but it worked. The amplified products sequenced and analyzed, and subsequently phylogenetic analysis showed 3 topologies. Here, the 3 topologies that were separated into 2 major clusters. The first cluster, we see the apis here on the top in pink. And the second clusters, we see the Kalulut honey, the Trigona species. The apis honeybee groups actually contain another 3 subclusters. Here, 1, 2, 3. If we look carefully, the Melisphera and the Chorana are nearer to each other because both of these are cavity nesting bees. Compared to Dosata, Dosata is the giant honeybee. So that shows the topology. For edible bird nest, principal component polymer PCR amplification, that's polymerase change reaction, was at longer base pair length of 1,100 base pair. So the cytochrome B is taken as an example, and the topologies also show clear and distinctive groups of the white nest and also the black nest. Now, moving on to the second section on quality, health, and sustainability, my food engineering research was mapped to its outcomes in terms of quality, health, and sustainability with engineering mindset and approach. First, by means of using technology, because I feel new technology can give us breakthrough to improve processes. Second, by the use of analysis, because accurate analysis and precise quantification is very important. to judge if a process is good or not. And thirdly, by modeling techniques, where we as engineers love to do that. We do prediction, we do optimization. So using technology approach, the ultrasound was used to improve texture and shelf life of several foods, which include the breads, the cakes, and we have also used it for guava drying, extraction of good biochemicals from the mangosteen, and the ultraviolet C was used to enhance tomato shelf life. Okay. Ultra high-speed blending at 22,000 revolution per minute, RPM, was used to make peanut butter without using stabilizer and preservative. And high pressure processing was tested for milk and honey in search of better preserve of nutritional qualities of the food. This is the picture of the HPP machine. The anaerobic digester was used to produce biocompost from food waste that is useful to grow vegetables in addressing process sustainability. This is the biocomposter. In analysis aspect, to improve quality of food in terms of texture and shelf life, various equipment to measure density and texture were used. They include a very high speed, very high-end pygnometer and rheometer. Yeah, I did a lot of testing for densities, especially. Bubble size distribution analysis were also developed using X-ray tomography and microtomography. For the section on health and nutrition, studies on antioxidants and hydrocolloids were aimed to improve processing of tropical fruits, to get better nutrition. Bioinformatic analysis from DNA studies were used on foods such as honey maturation, keeping honey for a long time to see what happens, sourdough bread, and also kombucha. For sustainability, food fermentation process is next to be explored because I love the process. It is clean label products and it is a very sustainable process worth knowing more. I'd like to share some exciting pictures of analysis using X-ray microtomography and tomography, which we use to measure and analyze 2D and 3D foam and cake structures. Very high-tech, but very accurate and useful. They have helped us a great deal in analysis of bubbles in terms of their numbers and sizes. So this shows the platform where we place a cake, whole cake, for X-ray tomography setup. And now what you see is the 2D images on the top and the 3D images of an aerated cake structure, where we use them for bubble size analysis. This picture shows the effects of using ultrasound treatment during mixing cake batter, where we see smaller and tinier air cells. We see a nicer cake, not like this, when we use ultrasound treatment. And more images of aerated cake structures made using whey protein this time because of the aerated angel food cake. So the ultrasonic treatment definitely gave finer texture. Here is an example showing results of the detailed analysis of bubble sizes and frequency. For a size range of very small bubbles, we see there is an increase from 94% to 95%. And in this graph, with a higher cumulative number for the treated sample, that definitely tells us smaller bubbles, more in quantity. So the last approach that we have used was modeling. It was done either for optimization or for prediction purposes. The RSM, famously known response surface methodology, was used to find processing parameters where we want certain responses to be maximized or minimized. For example, if I were to make a processing, I want the antioxidants to stay high, to maintain high. So I will choose maximum. Okay? For color deterioration, I do not want a poor color after drying. I will choose minimize changes. That is RSM. For the case of antioxidants as response, we will want maximize, like how I explained. So pattern recognition methods, master curve models, and geographic information system data were mostly used for prediction purposes. The modeling projects all have looked into minimal processing from the energy aspect. This is a picture of the contour plots of the RSM, where we see the blue lines. We do optimization and then we do verification to check if those are really the optimized points. So, we have come to the conclusion. The conclusion of my lecture today is that both aeration and authentication studies in food engineering are relatively new, but they are useful in the course of producing quality food, emphasizing the nutritional aspects and not forgetting the sustainable issues to the environment. Being a food engineer, I feel it is advantageous that we can use technology, analysis, and modeling to help in our work. Specifically, in my case, I have used power ultrasound, X-ray tomography, and modeling tools. Along the three basic characteristics of food, which are physical, chemical, and biological properties. The students will know this very well. With that, I hope my lecture have given you some insights about food. Thank you very much for your kind attention, and I hope the field of food engineering and food engineering graduates here will continue to shine. For all the results presented, I would like to acknowledge my students for their hard work and diligence in producing excellent work. The materials presented here can be referred in the inaugural book with references at the end for the published journals. Here is a list of my master's students. Dr. Dayang, Nurul Fairuz, she's here today, I know. Dr. Yanti Maslina, she's now with UTM. Dr. Chok Chun Yong with UCSI. Rohaiza with she told me it's an Institute for Halal Studies. Dr. Norazlin with UTHM. Yo Chuyen, Teng Li Yuan, Dr. Tan Mei Ching, most of her work on aerated cakes are actually from her. She's here today. Dr. Marjan, she's now in New Zealand. Dr. Kwek Mei Chen, those on edible bird nests are from her. Dr. Kek Siok Peng, in TAR, you see, the ones from honey, the ones on honey are from her. Abu Bakar, Dr. Liu Sanchin, Lim Wei Jie, Iswaiba, Dr. Chong Kain, Dr. Johnson, who is from Nigeria, and my current MSc students, I have two of them, Zichi and Venice Chua. And these are my PhD students, from which 5 have proceeded to do their PhD with me from their masters. To add on to the list, we have Dr. Nasro Fikri, the ones on bread are from him. Dr. Norazatul Hanim, the ones on peanut butter are from her. Dr. Lee Lai on emulsifiers is from her. She's from the industry actually. She did her engineering doctorate with me. And my current PhD students, 5 of them, Su Kang, An Chi, Siu Wen, Su Hui, and Su Ping. So my appreciations and thank you to all my funders for providing fund, collaborators and organizations supporting my research in one way or another. And to my seniors and mentor, I want to say thank you. Late Prof. Radin, Datin Aini Idris, Dato Saleh Jaafar. My mentors in the UK, Prof. Grant Campbell, Prof. Keshavan Niranjan, Dr. Frank Thompson, they told me they are watching live from the UK. And mantan dekannya, Prof. Fakro, Prof. Asmi, Prof. No Kamaria. And my lecturers during my bachelor days, Dr. Nordin, Dr. Johari, thank you for coming, Dr. Hussain. To my school teachers, because they have helped to shine my path. Miss Catherine Tan and Mrs. Michelle Ng, both of them are from Malacca. And it's now the turn to my children's teachers. Thank you so much for helping to guide and shape them. Dr. Chong, Ku Wing, Teacher Roy Yap, Teacher Miss Lee, and Mr. Tan from Junior Art. Last but not least, in my list of acknowledgement, I like to thank my department members, Process and Food Engineering UPM, and faculty members, which is engineering faculty. Thank you so much for having me, providing me the best ground and support. Thank you to Prof. Siti Mazlina, Head of Department of my Process and Food Engineering, and also to Prof. Cairo, my current Dean. And to this event's organizing committee and secretariat, thank you so much for your great commitment and making this a success. Puan Ilawati, Encik Iswan, Puan Aziza, Eja, and all others without mention. I would also like to apologize for any shortcomings in this lecture and event. Before I end, do you know who this boy is? My son, okay? I'd like to share with you about two things. One is the announcement of my coming book titled The Art and Science of Aerated Foods, anticipated to be out in the market later this year. Now, if you're interested in some science of food preparation and particularly on the aspects of food aeration, this book shouldn't be missed as it is very, very unique. It has both the theory and the practical sides about preparing aerated food. This is the sourdough bread I made at home. So each of the 28 recipes in the book was carefully researched, studied, tested, made, and refined in my home kitchen over a period of 3 years. To exemplify aerated food making, along with the science explanation with the help of Professor Grant Campbell, I call him the father of food aeration studies. This book project was mooted 4 years ago in 2019, but it did not pick up well due to several serious lacking. But one fine day I woke up and I told myself, these things have to be documented so that more people will appreciate food for its aeration. So today, I'm just able to provide you a limited snippet of it. Do look out for it by the end of the year, and it will be by Springer. So, it looks like that's the end of my slides. So the second thing that I would like to share with you is I have prepared a montage myself that I want to share with you the journey to where I am today. And I would like you to watch it and please enjoy. Please, the Secretariat, you may play the montage from your end for a better sound system. Thank you. After 30 years leaving school, in the secondary school, I had a lot of exposures. We studied hard and also played hard. Raja Permaisuri Agong Tuanku Najiha, it was a very memorable thing for me. my teacher. She gave us lots of encouragement and to believe in things that we do. In UPM, LKL 222, under the hot sun. Yeah, a group of friends in the sawah padi, and we also tanam the jagung. So now I know jagung quite well. And in 1996, I chose food engineering, the first batch program launched. I had a brother and a sister also in UPM, giving me the spirit, and I graduated in 1999. At the time, quite a young age, I was confused. But then I was very, very lucky. I got a tutorship and scholarship from UPM. I went on to further my study in UMIST. I visited Dr. Nordin recently, and he was so happy to see me. And of course, Dr. Johari, he made us think, try, never give up, and always be brave. These are the days in UMIST. The days were tough, but we had friends. This is my volume displacement, measuring density. I did hundreds and thousands of dough a day. And I graduated from the Chemical Engineering Department. Thank you so much, Grant. He is still my mentor today. We have friends, Dr. Zalini, Prof. Ida, Prof. Zurina, all are full-fledged now. I got married and became Mrs. Wong. Well, days continue in the faculty, in the school, in UPM, with students and activities. Research, professional extension, a little bit of work in IEM, interviews, and also competitions and awards. Yeah, this was in 2012 for the Anugerah Fellowship Knight Chancellor and also various others. Say thank you to the late Datuk Radhi Umar and Prof. Datuk Dr. Saleh Jaafar. Along the journey, I became a mother. 2007, my daughter, Jai, she's here. 2013, after a gap of 6 years, we waited so long, Jaren came. We were so happy. This is my lovely family, all of them are here. This is my husband. I'm so much in debt for his love and encouragement. My siblings, brothers and sisters for their love, care and support. My late grandparents, I learned what was hardship and hard work. My dad, I learned patience, and my mom, I learned strength. My dad say, hold a pen, it is the lightest tool, and I remember that. Thank you so much to all of you for being here. Thank you so much.
Terima kasih sekali lagi, berikan tepukan gemuruh kepada yang berbahagia Profesor Insinyur Dr. Chin Nyuk Ling di atas syarahan inaugural sebentar tadi. Sangat berinformatif dan memberi inspirasi kepada kita semua. Baiklah para hadirin sekalian, saya minta Prof. Chin untuk kekal berada atas pentas. Majlis dengan ini ingin menjemput yang berbahagia Profesor Insinyur Dr. Muhammad Khairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan, untuk sama-sama tampil ke atas pentas bagi sesi penyampaian cenderamata. Dipersilakan. Kepada Prof. Khairul untuk menyampaikan cenderamata sebagai tanda penghargaan kepada yang berbahagia Prof. Chin. Terima kasih diucapkan kepada Prof. Khairul. Diminta untuk Prof. Khairul dan Prof. Chin untuk kekal berada di atas pentas. Sekarang majlis ingin menjemput ahli pengurusan Fakulti Kejuruteraan untuk sama-sama berada di atas pentas bagi sesi bergambar. Dipersilakan. Terima kasih. Sekarang majlis ingin mempersilakan kepada tetamu jemputan kita iaitu ahli-ahli keluarga yang berbahagia Profesor Chin Nyuk Ling untuk sama-sama naik ke atas pentas bagi sesi bergambar. Dipersilakan. Majlis merakamkan ucapan terima kasih kepada ahli pengurusan Fakulti Kejuruteraan atas sesi bergambar. Diminta kepada Prof Chin dan ahli keluarga untuk kekal berada di atas pentas. Terima kasih diucapkan kepada Prof Chin dan juga kepada ahli keluarga atas sesi bergambar sebentar tadi. Baiklah para hadirin sekalian, sekarang saya ingin minta kepada semua untuk berdiri dan bergerak ke tengah auditorium kerana kita ada satu sesi bergambar beramai-ramai. Jadi diminta kepada para hadirin sekalian untuk berdiri dan bergerak sedikit ke tengah auditorium untuk sesi bergambar beramai-ramai. Dipersilakan.